Okay, well, while more people is joining, please remember, I'll say that again later when we start. But basically, remember when you use the chat to do it to all panelists and attendees to make sure that if you're posting something there, also your colleagues can see it, unless it's something you want to comment to only to the panelists. Also keep in mind, for me, once I'm sharing the screen, will be much more easier for me to actually see the questions and answer Q&A section rather than the actual chat. So I'll try to have a look at the chat as well, because sometimes there might be something there. But if it's actually questions about all the different things we're going to discuss, it's better in the Q&A. All right, so I think it's already a couple of minutes from the time in which we are supposed to start. So let's kick this and keep running. So welcome, everyone. We have some people with us today. As you know, this is one of the office hours that both Carlton and I are going to be hosting every week during all this course. As I said, you can feel free to interrupt me at any time, post questions in the Q&A. I'll keep an eye on that. If by any chance I don't see it right on the spot, I will probably go back to them along the office hour. And the idea, I mean, is to do this also quite interactive. It's difficult because it's a chat with me talking, but I would like this to be as dynamic as possible. So let me share the screen with all of you. I have prepared some slides mostly to help us to keep some kind of agenda of what we are going to do. So basically, let's see, presentation mode. All right, so let's start giving you a bit of idea of what I have in mind for these office hours. So basically, as you know, office hour from Carlton is on Friday. Myself is on Tuesdays. The idea of having two of them is we will try to have them as, let's say, mirrored but complementary as possible. So the idea is that more or less the same things that he covers on Fridays, I'll try to cover something very similar on Tuesdays. So let's say those of you that for some reason 1 week cannot attend the live session with Carlton, but can attend with me, or vice versa, you are not, let's say, penalized by missing one of them, but you actually, let's say, have these two opportunities to more or less get the same learning process independently of what office hour you join. Then, because of course of both Carlton's and I background, the office hours will be also complementary. So some of the things that he might cover, or the approach that he takes to some of the topics, might be a bit different from the approach that I might take, or sometimes maybe he's more into coding, I'm more into applications, or vice versa. So again, some kind of having a more or less average mirroring of both sessions, but also complementary. Then please keep in mind always that the idea for both of us is, I mean, we are learning facilitators. So basically we are here to facilitate your learning process. So we'll do our best to provide additional resources to walk you through some of the material cover. We won't be covering new material or making new explanations here. For that, you have plenty of material in the course from the professor with videos, with activities and things like that. But we will try to help you go through all these materials, or providing some additional practical sources for you to work through that. And then the other point I have here is, remember that any questions at any time, please type them in the Q&A. I have it here in another screen, so I can be checking that while I'm talking. So the idea also for today would be to give you, let's say, some practical notes that will be helpful. I mean, this is, of course, the first office hour we have. We don't have so much material right now at this point to really go much more on detail. So the idea is to go through the main very high level ideas that we have released and you have seen already this week, and also some practical things of how to work with all the different resources and tools that you have available, not only for, let's say, the learning process in the course, but also for you to actually get more into the practical implementation of machine learning methods for decision making or for any kind of application that you might be interested in. I have gone through all your different profiles. It's very interesting that, I mean, we have people from different backgrounds, people working in finance, in banking, mining, and then many different places of the world, from, of course, UK, but also Chile, Singapore, China. So that's also very interesting. I hope that both during these live sessions and also during the forum that we have in the online platform, we can have a very nice interaction between students and facilitators, and also everyone feels comfortable to contribute, to ask questions. There is never silly question, please, no matter how obvious you think it might be, or simple, or high level or low level. I mean, just ask the question. No, don't hesitate to do that. I would also encourage you, while I was going through the profiles of everyone, some people has filled it up, some people don't. I think is also good for as a networking opportunity for everyone to know what others are, from what backgrounds are coming, why are they interested on that. So I would encourage you to also fill this up. Okay, so let me also now go quickly here. So this is, as you know, this is our online platform. We went through that the other day. I would like only to emphasize something that I saw that the other day with Carlton was not working yet, was the forum. So basically you have your news feed here. You have, of course, the different weeks with the materials. We're in this week 2, so we are already in the introduction to machine learning. You have a lot of different general ideas of what we're going to cover. There is a question from Yatil: how much of the background of the theorems it is important? And so I think you all see it, but how much of the background on the theorems is it important to know prior to the progressing of the modules? Well, I mean, we are assuming that you might have very little, in some cases, almost no background on the theorems or algorithms, or even in the math, these underneath all these techniques. So the idea, I mean, it depends on, of course, on your background, your knowledge, and your interest. There might be some people that they will have maybe a very strong background in mathematics, in statistics. Maybe they have a strong background in coding. And then with, let's say, the tools and the resources we're going to provide, that people might be very quickly, let's say, going farther into, or getting into coding, into touching or changing some of the methods that are implemented in that coding. Some other people don't, and maybe you are more interested in understanding conceptually how this works. What do we use it for? What are the, let's say, the speak that language, in order then to be able to interact with others in the field. So don't worry if you don't have, let's say, a strong background on that. You should be able to follow. And if by any chance there is something that we, because we're in the field, we give it for granted, feel free to stop and or to either in the forum, in the send desk, opening a ticket, or reaching out to us here in the live sessions and say, look, I don't get this. Maybe we can go through that. No problem. Something I forgot to say before, now that I remember, speaking of backgrounds, something that would be also a bit of a difference between Carlton's office hours and my office hours is, of course, coming from our background. So he, as you know, works in for United. He's, let's say, managing a lot of data coming from airlines, trying to predict things related to air traffic, to delays and things like that. There is a lot of data there that they are working with. My background is in chemistry, so I work in computational chemistry. So basically, this is, let's say, the use of computers for solving chemical problems. So I don't know if you have heard about what's called quantum mechanics and quantum chemistry, but basically there is an entire branch of theory, mathematics involved in, let's say, describing all these quantum mechanics systems like atoms and molecules using computers. So for that, we also can use indeed machine learning to predict chemical properties, to predict chemical composition, to predict reactivity, to predict, I don't know, to design new materials. There are plenty of applications in this area. The beauty of it, and this is something also important for all of you, is that if you think about it, as learning facilitators, we have someone who is working with, let's say, an airline, someone who is working in fundamental research of quantum systems and atoms and molecules. And then among yourselves, you have people in banking, you have people in mining. So this should give you an overall idea of how the wide range of applications of machine learning, because as you will see during these weeks, I mean, we're going to talk a little bit about it now. At the end of the day, it's about data. And then the moment you have a lot of data, and then you have a lot of variables, and then you want to know, let's say, what are the relationships in between all this data. You want to analyze that data and to make predictions. You want to infer connections in between that data. So all this, at the end of the day, let's say the algorithm or the method you use in machine learning doesn't care, if you want, if you're dealing with data coming from airplanes or you're dealing with data coming from electrons moving in an atom. At the end of the day, it's data. All right, so coming back to here to the screen, I was describing you are already, I would advise you to get familiar with this, but basically you have all the information per week. You have seen that in these weeks you have a lot of different videos and active exercises. You have then a forum that the other day was not working well, but here you can see it works now. So there is, for instance, here a question on what is machine learning. So you can then click and then you can see, let me see, it's not loading well. No, these are the videos. So where is the forum? All right. So I was actually looking at it, but now it's not here. So you can see the question. So Christian was asking this question to the whole, is a whole class discussion. So you can always interact with that. You can, so here is the question. Hi there, Christian, respond. So I would, of course, myself and Carlton will do our best also to promote, to interact with you guys, to open discussion forums, but feel free to, if one colleague is asking this, feel free to use it. It's good for debate and discussion. All right, so Let me come here again. So the other thing I wanted to share with you is that you will see in many cases that we will be talking about Python, we'll talk about Jupyter notebooks. There are different sources that is important for you to get familiar with. And that goes again to the question from Yatil about the background needed. Depending on your background and your interest, then you can go farther or stay a bit in the higher level. So if you go, for instance, there is some additional material provided in the module. And let me, I'll go to this later, but let me first show you a little bit. We will be talking here. So if you go here, I don't know if you're familiar with Python, but Python is the main or one of the most used coding programming languages nowadays in science. So if you go python.org, you have everything, a lot of resources to learn about Python, how to code, how to understand. A very easy and good practical way to practice and to learn is the Jupyter notebooks. So here, jupyter.org, don't worry, because we will, as soon as we are using those in the future, maybe you are already familiar with it, but if not, we will walk you through this. Here you have the Jupyter notebooks. Basically, it's a way to actually type your code in a very easy to handle, easy to see the result, and a nice environment for coding in Python. Good news is that no one expects you, and even myself, I won't probably be able to do it, to get an empty notebook and write anything from scratch. But many of the examples you might see, and we're going to see some now, are wrote in such a way that then you can execute them, see the outcomes, and you can actually change them. You can edit that code and see, okay, if I change this variable, what happens? If I delete that line, if I add this other thing, you can interact with that. And that Jupyter is very useful for that. Is there a question? No. Okay, going a little bit through the main things we have seen this week. I would like to emphasize some of the things. So conceptually, you should, I mean, you've seen it in the videos and in the material, but keep always in mind that what we are trying to do here is to effectively analyze complex data. So we have large amounts of data. We are trying to find patterns that are not easily realized by humans when you just look at that data. So the idea is that we can actually get that information from the data for two reasons, as you have seen already. We want to make predictions, or we want to understand or to find some kind of connections. So basically is that, and that's the main idea you have, is take-home message. We want to have data-driven decisions. So we will see plenty of examples. For instance, one of the examples that we both, I mean, Carlton was also discussing is that, I mean, is this one here. I wish I know what the stock price of a company will be tomorrow, so I can make my investments today, right? But for that, we need to capture, ideally, all the factors that affect that price. That's, of course, impossible. So we can have certain things that we know might affect, therefore build a model that help us to predict what's the outcome. But there are many factors that we cannot predict. I mean, and therefore we need to deal with that uncertainty. We need to deal with that noise. And that's why we were in this simple expression that the professor was describing. We have our why, we have our variables x1 to xp, and then we are trying to find this function, right? This function is what connects my data, the x1 to xp, to my actual outcome. Now there is this epsilon here, which is the noise. I mean, we cannot, of course, sometimes we can have a very good model, we can have a very good understanding of the field. Maybe that noise is very small. Sometimes this noise is going to be larger. There are even systems that are intrinsically stochastic, that by definition, you cannot predict them. You have to work with this kind of uncertainty. So for instance, here is asking, can you determine what exactly is E? No. I mean, that would imply, I mean, maybe if you have a very, maybe if you are building a very simple system where you have a very defined data, in which you have mostly certainty of all the variables that affect that, maybe you can actually reduce it to a very small number. But in most of the cases, in real world applications, there is some noise that you cannot reduce, you cannot predict. You have to deal with it. Of course, we will see that there are different ways to mitigate that as much as possible. Then I was also saying that, for instance, in chemistry, in chemical systems, electrons are, you have heard of the principle of uncertainty, but basically electrons are inherently unpredictable. So there is a fundamental principle in quantum mechanics that tells that it's impossible to know, in this case, the position and the velocity of the electron at the same time. So this is intrinsically unpredictable. So you need to deal with a stochastic system by definition. You cannot make it, let's say, more predictable than that. I mean, you need to deal with that noise. So theory, so how would it work for a stochastic use case? What would the epsilon be in this case, or how will you come up with the number? We will see how we deal with that kind of uncertainty. I mean, we cannot get right now very much in detail about that. I mean, that's what the course is like. So let me see that in this formulation, when I put the epsilon there, this epsilon is not a variable that we are going to predict that number. So it's a way to express here that in my connection in between this y and this data set x1 to xp connected through that function, there will be something there that I don't know, that is making some noise. It's not that we are gonna come with, okay, epsilon is 5. Because if epsilon would be 5, then we would have a 5 factor embedded into f. Then my function would be already well defined. Epsilon is a way that we have here to conceptually express there is something else there, which is the noise, which is out of our function that connects the input and the output, and that we have to, we hope that we will have the way to make it as small as possible. But it's not like a variable that we aim to determine with a number. I don't know if that's theory, that actually answers your question. Okay, great. Then the other, you saw, here I try to summarize some of the different things that we have seen this week. So you have seen many different names and ways to refer to things. We've been comparing continuous versus categorical, supervised learning, unsupervised learning. We have talked about regression, classification. So let me here somehow summarize this and walk together through a very good examples to understand it. So basically, if you have seen already what we discussed, for supervised learning, we would have continuous or categorical. So basically in the continuous, when your input data set has continuous values. While in the categorical is a yes, no question, or some kind of, we were giving that example of cancer, for instance, type B cancer, type A cancer. Very good example of, to understand all these different things, I think is very good for you to go to this link. This is provided in the online platform, so you can have access there in the same place where you have listed different books. You also have access to this information. So there is a link to something that says what is machine learning. So if you click there, I have opened it already here. You go to this website. What is machine learning? So I think that reading this, it won't take a lot of time, but it will be very good at clarifying all these different concepts that we have covered this week. So if you come here, it talks actually about what we just said. So categories of machine learning, you can see here, supervised learning and unsupervised learning. So in the supervised learning, let's say you have your data, and you also know what is the labels associated to that data. So, however, in the unsupervised, there is no such a label. I mean, it will be the analysis itself that it will find out, and it will tell you if there is something to label somehow. But there is not such a initial, let's say, restriction, which is actually the supervision, right? That's why it's supervised. So some examples, I like this because it gives you a lot of examples. So for instance, imagine you have this, look at this graph here. I think everyone can see it, right? Yeah. So you have, this is your input data. You have, this is supervised learning because to start, you already have your feature 1, your feature 2. It could be any 2 features, that's what you're studying. But then they are labeled already in blue and in red. So what you need to find out is what's the connection in between these 2 features and being red or being blue. I mean, in that case, it's pretty obvious, let's say. I mean, everyone could say, okay, well, I mean, it seems to be a line here. So if my value feature 1 and feature 2 is on the top of that line here, it's going to be blue. If it's below that line, it's going to be red. So indeed, my model would be, let's go to the graph here, would be a linear regression, linear function that divides my data in such a way that having this model, I can now make predictions. I can go to whatever feature 1 you want. I can go to whatever feature 2 I want. I put them together, and because I already have the equation, let's say the expression for that line, I can see, okay, with this feature 1 and this feature 2, my point is going to be above the line, so it's going to be blue. If it's below, it's going to be red. So that is supervised. Of course, again, I mean, think about this. I mean, we are developing these things for large amounts of data where it's not that obvious. So here we saw, okay, it's blue here, it's red here. But imagine when you have millions of data, everything is mixed. You look at that and you see nothing. You need to find a way to see, okay, is there some kind of pattern I'm missing that I can then figure out somehow? So another good thing of this website is that it provides, see here, figure source in appendix, or here, figure source in appendix. It gives you some code. So if you click, it opens actually the Python code they used to generate such figure. So this is very useful, and that goes to what I was mentioning at the beginning. It's good to get familiar a little bit with Python and with Jupyter notebooks, because now you have this code here. You could copy that code. You could post it in your Jupyter notebook, and you can interact with it. You could change it. You can see how these guys made this process. You can play with it as well. So again, this is why I wanted to link this to, let's say, the Jupyter notebook, as well as to the Python. So let's continue. This is, we said, this is supervised. So they are already labeled, and we just need to find out what's the relation. And we say, well, a linear function already tells me the connection in between the two features and being red or being blue. So now, because I know this line, so I know the line from here, I can get now a data set, which is totally different. All of them in gray. I put my line that I have from the previous data set, I draw my line, and everything above is blue, everything above is red. So I have made a prediction on how these dots are going to be in the label color based on the training that I did of my function with this data set. So we will go through this then in detail. Some examples here of that. Naive Bayes, we have a live webinar on this. So these are many things we are going to cover this week, but it's good for you now to give a good idea of what we're talking about overall. Now, imagine, and what we're saying here, we said here, continuous or categorical. Categorical, being blue or being red. Continuous is that you can have then different colors that go from this yellow, green, blue, purple. So there is a continuum range. How do I classify them? Well, then what we can have then is another label. My label now is continuous, and I can represent it as the height in there. So basically your feature 1, your feature 2, and then the label, the color, the higher it is in this third axis, the yellow is. The lower it is, the more purple. So I have changed this continuous color coding into an actual number. I made it a number, which is just a scale going up. And now instead of a line, I can have a plane. So I can draw a plane here, and that plane will tell me then how, based on where they are going to have different colors. So it's a continuous description of it. But now instead of having a line like I had before, this line was telling me blue or red. Now it's a plane with this color is telling me the actual color of the points. It's a different function. My f is different now. It's more complex. Now, if I get these gray points here, plot them there, and based on their position, they will have different colors. So these are the kind of ideas of, or more practical implementation of what we have discussed this week. Now, this is supervised. So let's think now about the unsupervised. Let me get some water first. So, excuse me. For the unsupervised, we said we don't have this labeling. We don't know the label. We don't know if it has to be blue or red. We don't have it if it has to have continuous values from yellow to purple. We just have our data, and we don't make any initial assumptions of how this data is going to be labeled. So imagine you have this. Again, these are examples, so it's pretty obvious. If you look at this data, there are some kind of clusters. So we will go again, also through what's the clustering process. But basically, it's going to be my algorithm, my method, is going to tell me already, okay, here you have 4 different clusters. Basically, it's going to create for you 4 different labels. Maybe cancer, imagine is cancer. Cancer type 1, type 2, type 3, type 4. or many other things. I mean, for instance, in computational chemistry, we want to study the shape of proteins. But the shape of proteins change with temperature. So there are many different possible structures for a protein depending on many different variables, depending on temperature and pH, depending on pressure, depending on external things. So basically, there's a clustering process to say, okay, based on all these variables, the most likely structures you are going to find are grouped into these clusters. And then even though you cannot look at all of them, at least you can categorize them into discrete numbers of labels. So here is the same. You have your feature 1 and your feature 2, and then you see that it creates 4 different clusters. So it's going to be your algorithm is going to tell you, okay, these are going to be the blue ones, the yellow, the purple, the green. You didn't tell in advance these 4 colors. I mean, its colors could be something else, but basically is the method that with this unsupervision is telling you identify that there are 4 different types or categories in here. I think I've seen a question coming, but it's not in the questions. Maybe it's in the chat. Let me, where is it? So there was a question, but I didn't get it. So if it was in the chat, please could you share it again? Or let me see if I can see it here. Chat. Okay, Laura says, so a protein folds differently depending on the temperature. Yes. So basically, when you have higher temperature, the way that protein is folding is different if you are at lower temperatures. Actually, quick example, and I'm sorry for getting into that chemistry part, but it's answering to the question. When you are cooking meat, it releases liquid, it releases water when you're cooking it. The reason why it happens is because when you increase the temperature of the proteins that are in this meat, they change the structure. When it changes the structure, it releases the water, which is otherwise locked into the structure of the protein. So that's one of the examples how proteins change the structure. These kind of things can be predicted by using clustering methods. So we can, these features, feature 1, feature 2, many more features are these kind of, it could be temperature, it could be other things. And then it will tell you, depending on at this temperature, at this pressure, at this humidity, at this pH, your protein is going to have this structure. And then when you change all these variables, maybe certain, you end up with, because there are many different variables and they are interrelated, it will give you then same more or less structures. It will create a cluster. Of course, understanding that just by, let's say, looking at the data, or we thinking about, okay, what happens is if I change this or that, is very hard. Now, if you have a very good predictive machine learning method, that can it would tell you, it would predict to what cluster it would belong. And I'm talking again about proteins, but we could be talking about customers, or we could be talking about many other things. It's the same. Maybe we find out certain clusters of customers for our business that they always behave the same way, and they follow a pattern that we didn't expect, that we didn't realize. So this is an example of clustering, and we will have a webinar actually on that. Let me keep the question and answers opened. Yeah, great. So then another example is dimensionality reduction. So that's something we also saw. It's in the, is also here in this. So in this table, what we just saw is clustering. So basically, we identify distinct groups of data, where otherwise we didn't notice. Dimensionality reduction is like we find more succinct representation of our data. Again, in this website, they give you very obvious examples because they want us to actually realize something is going on. The beauty of this is when we can find this in data that to us it looks like a constellation of stars, and suddenly these patterns are found. So for instance, here, if you look at this data, it is complex, but it's type of data. So if it's moving through the spiral, at the end of the day, it could be understood as a linear model, because you can just move through the spiral as if you unfold it, it would be a linear data set. And basically what they do with that method is, you can see here that as you move linearly through your data, you go from the yellow to the green to the purple. By the way it is generated, it forms that kind of cluster, or that kind of constellation in spiral way. But then you can then do this dimensionality reduction, something which is more complex in more dimensions. You can reduce it to a system which is more simple. We can reduce something which is spiral, looks like a cloud, maybe can be reduced to something which is a line. So this is the dimensionality reduction. So again, I think it's very useful to have a look at this, read it carefully. I mean, it's very easy to follow. The examples are pretty obvious when you look at them, but the idea is that you get the main concepts, because at the end of the day, the real data we're going to work with is going to be so complex that, of course, when you look at it, you're not going to see it. That's why we are doing this, right? But basically, if you think about it, what we saw is exactly this. I mean, you can see that all these concepts that we've been discussing this week about supervised and unsupervised, this supervised with regression or classification, continuous or categorical, dimensionality reduction, clustering, all these concepts that we have in the videos this week, that we have in the activities, they have a practical implementation. So through the examples we saw today, you can actually see this. You can link to the code. It's good to start thinking, okay, I know about the Jupyter notebooks. I know about Python. Again, we don't expect you guys to know all that, but it's good that you know it exists. You know that these concepts are implemented into a coding program, which is written in a language called Python. You know, it's good to know that Jupyter notebooks are an easy way to actually see how these codes work and get familiar with all this. We still have 15 minutes. I'm going to stop here a little bit to see if you guys have any other question before I continue with maybe a couple of more things I wanted to comment. All right. Okay, so another thing connected to this, in the same place where you have these sources, I think it's in here when you are in the first one, learning outcomes here, supplementary readings. So the link in which I was right now walking through is this one here. What is machine learning? Of course, everything here is honestly very, very useful. I would also maybe comment on this book. Where is it? Yeah, hands-on machine learning with scikit-learn and TensorFlow. So these scikit-learn, TensorFlow are very used programs, software for working with machine learning applications. That book in particular, there is a question from Thierry. Hey, on the homework where we need to share a picture of an ML example. I don't know exactly what you mean. So if is it for the homework this week, or are you talking in ahead when we are going into the from week 6 when we have different homework? I'll read you. There more. Week 2, think module 2.5. Let me see what you're talking. Yeah, here. Okay, I know what you mean now. Well, I mean, the idea of this one here, you see some colleagues already posted things here. So basically, it gives you some examples. So again, this week is being very broad, high level. So at the end, in the 2.5, there were some examples in which this type of machine learning methods have been used. So it talks about the DeepMind project from Google, where you see how it works with imaging. It talks about the Google Translate and how it's being improved to actually work with words. That's another important field. We will talk about that when we talk about naive Bayes. So basically, this is another example for translation, and then you have another one from Facebook, the TorchNet, and this other. So what we expected here is for you to give it some thought. Okay, these are examples we have provided. What other examples can I think of, and then share with my colleagues. So basically, people has, for instance, Neil has shared with us this machine learning using detection of age-related macular degeneration in the eye. So it's used, there's an example here of this macular degeneration. So probably there is a machine learning method that can tell you or predict based on this imaging. This is a big field in healthcare. Based on the imaging, based on the pattern of certain dots, predict, in this case, if someone has macular degeneration. It could be something, some other things. I mean, analyzing X-ray, where there are certain things that maybe, of course, a very an expert, a very good doctor can look at the X-ray and say, okay, there is something wide here which is unusual. I think there might be something not good in there. Can a machine learning that has been trained by looking at several millions of X-ray can then predict, if you give a new X-ray, to say there are certain patterns of dot here that is telling us that something is not right. So these are the examples that we ask you to share with that there is an example here about football as well. There is another in healthcare related to atrial fibrillation. So that was the idea. Yes, coming back to what I was saying is this, let me see, the book that was in the here, that's the book. And the good thing of this book is that I would also encourage you to go, let me see if I can, sorry, because when I try to change the browser, here. So you can go here, this GitHub. So all this material here is made by the same author of that book. And what you have here is the actual code that you can play with. And here, for instance, you have plenty of them. You have here one, that number 2, end-to-end machine learning project. You open it, and it's full of comments. So welcome to the machine learning housing corp, you task and blah, blah, blah. Setup. First, let's make sure that our notebook works well. So then you have the code. Then get the data, and you have the code. Then show the data. You have it here. It's for housing in California, I think. So you have more code here. Then some analysis of that data. And in the end, if you go to the very end, I'm not going to go, of course, at this point through all the coding, but you can see this is California. And it can predict the areas where it's going to be more expensive. And then you have all the code of how that works. See? So the idea with that I would like you to take at this point, and don't worry because I don't want to overwhelm you, is the first week. But basically all this here is a very good resource to keep in mind. So you have the book, and then you have here this GitHub, where you have a lot of different coding. You can get that code. You can then post in your Jupyter notebook. You can play with it. You can generate that graph. What if, I don't know, you change data set, how that changes the prediction? It's a very good source to keep in mind. And that's more or less. I had a final slide, but was just to discuss with you and keep in mind about this 10 steps process. There is just one thing I would like you to remind that is important, is that we represent it as a linear process, but it's not always linear, in the sense there is a lot of loops and iterations there. So for instance, everything that has, I mean, the professor explained that very well in the videos, but then you have everything there about how to obtain the data set, how to clean it, how to then do, if possible, that dimension reduction that now we have seen in practice what it is. So once you have all these things that are very time consuming, you might get, for instance, to the moment in which in step 8, you are using the machine learning technique that maybe is not working well for some reason. And maybe you need to go back to the step 2 before continuing. And that's very common. I mean, sometimes you need to iterate, and maybe even the process of 2, 3, 4 might take a while. You might need to go back and forth. You might identify some kind of bias in the data because of how the data was collected. There could be some biases in the data. There could be some biases in the model. I mean, all these things are things we will discuss, we will have to think about. At the end of the day, the data is collected in many cases by humans. The algorithms are also developed by humans. So there is some implicit biases that we might not even be aware of that. So there are a lot of interesting discussions here that is good right now for me to open the floor to that through these weeks. But I hope all this discussion will be coming back and forth, and we will be interacting through this. So I think at this point, I have probably talked too much. It's good that, I mean, it was not even me telling all that story, but you guys also, I see that a lot of questions from your side. I would, for these remaining minutes, open the floor. If you have any other questions, just let me, before we finish, emphasize again that the idea here with that is to provide the resources, and for you to be aware of all the available resources that you have, to go more in depth or less as you wish, depending on your interest with all this. And again, I mean, don't worry if everything I have discussed right now sounds maybe a bit too much to start. I just wanted to give you a bit of overall idea in connection to the material of this week. We have plenty of weeks ahead of us for discussing more and for going in detail to mostly all the concepts we have talked about today. And yeah, again, you have this forum. I encourage you to use it. You have Zendesk to ask us any questions. So please don't hesitate. I think it's one of the good things of this course is not only the material that we are providing, but also is good all these debates and discussions and interaction between all of us. So yeah, I mean, hope you enjoyed, and thank you very much for joining the office hour. And yeah, I'm gonna stay around still for this 4 or 5 minutes. I'm looking if there are any other questions. Yeah, thank you too. I saw that in the chat. And yeah. Gonna maybe stop sharing the screen here so I can also see better the chat, just in case. See, for instance, I'm seeing now the comment from Jael about the how much mathematics he needed to study before week 4. No, don't worry. I don't think it's much more mathematics that I might need to study as well. No, but again, I mean, there are many. This is not a course on mathematics, on algorithms, on statistics. Of course, if someone knows and want to go more into detail, you saw in the examples today, there are plenty of coding there and even in other sources to play with. But that's the idea more is that you know more an overall idea of how to use this in a more high level. So Madwish is asking, where can I see Zendesk? Let me follow up on this because I thought you guys knew already from the reception the first week how to work with these kind of tools. So basically Zen, I mean, my accent maybe is Zendesk. I'll make sure to get back to you because maybe you have not been able to access or to work with it. So I just posted on the chat, and then basically in that platform you should be able to send 101 tickets. So you can post a question, and we should be able then to answer your specific question. The forum could be also an option, but let me then check why there is some reason why you don't know that, and I'll get back to you. Okay, so I'm actually, let me see. So Mawesh, actually in the learning platform, sorry, that was maybe I wasn't, I didn't know exactly how you guys work with it on your side, so I didn't explain it well. But in the learning platform, you can click on the help desk, sorry, on the help tab. And in this help tab, you can send a ticket to program support. So I was, I actually was calling it Zendesk because that's the way we see it on our side, and I thought it was the same on your side. So basically, it's the learning platform. You should be able to see a help tab, and if you type there to send a ticket to program support, then we will be able to figure this out for you. So any question, do it through the help tab in the learning platform. Yeah, I call it Zendesk because on our side, we saw it like this, and then I thought, I didn't know you saw it the same way from your side. All right, so if you don't have any other questions, we might call it a day. And yeah, and just again to clarify the thing about the question of Mawesh, is in the Incendi learning platform where you have this kind of tickets from program support, and then we will be able to answer the questions. All right, thank you very much. Hope you have a nice day, afternoon, or evening, depending on where you are in the world. And I'll see you again next week. Thank you. Thank you, everyone.